wish to move your data science career
Is my slide visible to all of you guys?
Yes, sir.
Yeah, so welcome to the week 6 discussion of this course, Introduction to Machine Learning. And this course was originally taken by Professor Balaraman Ravindran, Professor and Head of the Department of Data Science and Artificial Intelligence, IIT Madras, and myself, Ayan Paul. I am a PMRF Research Scholar from IIT Kharagpur, and I am a TA of this course. By TA, my duties are I will solve some question that will help to solve your assignment. Okay, so that is my responsibility. And so beside directly moving on to the question, what I will do, I will clear some of the concept of this week, so that whenever you are doing those assignment, you will not feel alienated. Okay, so welcome to this week 6 discussion. Last week we have discussed about neural network, okay, mainly about neural network. This week we will discuss about decision tree algorithm in machine learning. Okay, so what is this decision tree algorithm? Decision tree, it looks something like this. So what is this decision tree? A decision tree is a, okay, yeah, a decision tree is a type of supervised algorithm. Okay, so first thing that you have to note, it is a supervised learning algorithm. That means the input as well as output data will be provided to the model. First it will make the model, and then it will do the prediction. Okay, that is commonly used in the machine learning to model to predict outcome based on input data. Okay, they can be used to solve both regression as well as classification problems. So this decision tree is able to solve both your regression as well as classification problem. Okay, and last thing, it is a tree like structure. You can see this is a tree like structure where internal node test on attributes, each branch corresponding to attribute value, and each leaf node represent the final decision or prediction. So what does that means? You can see this is a tree like structure. Okay, so the top of the node, this is known as root node. Okay, this is known as root node or simply root. Okay, so this is the root node, that is depicted here by blue color. Okay, dark blue color. There are the second type of nodes called internal nodes or branches. Okay, from root nodes splits into many internal nodes or branches. Okay, these are known as branches. So it is denoted here by sky blue color. Okay, and lastly there are leaf nodes. Okay, the green color are called leaf nodes. So this nodes will actually give your prediction. Okay, and another thing about leaf node is it has arrow pointing towards it but not away from it. Okay, this is the classification of a leaf node. Again I am repeating, there are two main classification of a leaf node. First, the arrow the arrow will be pointing towards the leaf node and not away from it. Okay, first classification. And second, how you can know this is the leaf node? Second thing is, it is a leaf node because it will give you the decision or prediction. Okay, the prediction will be given by this nodes. So these are the leaf nodes, last nodes of your tree. Okay, and what are the branches used? Branches are mainly made of different input attributes. Okay, the characteristics of branches is it has arrow pointing towards it as well as arrow pointing away from it. Okay, so these are internal nodes or branches, that is denoted here by sky blue color. And the main node, that is a root node, that is denoted here by dark blue color. This is a root nodes or simply roots. Okay, so this is mainly a decision tree. This decision tree can do both this, can be used for both this problem regression as well as classification problem. Okay, so is this slide clear? Any doubt regarding this slide?
So
No, sir.
regression, how regression can be done? Can you give like a simple example?
Example means, see, classification, how you can do classification, we will see in classification. Regression, what we can do is, there is a continuous data set, 1 2 3 4 etc etc, right? 1 2 3 4 dot 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 dot, like 10. Okay, so what you can do is, you can probably what you can do is, you can probably form 3 or 4 classes, like 1 2 3, you can say, like this is say age. Okay, this is say age. So 1 2 3 I am denoting as young age. Okay, so 1 2 3 we can classify it as young age. 4 5 6 7 we can classify it as middle age. 8 9 10 we can classify it as the senior age, let's say. Okay, so by that you can change your regression thing to a classification problem, and apply in this tree. Like you can give it here a condition, if the your age is if you are young age, like if your age is less than 3, then it will split into two nodes. Similarly, if your age is between 4 to 7, this will split into another node. So that is how you can do this regression problem. Okay.
Okay, sir.
Okay, so no other doubt, right? In this slide, any doubt? Okay, but again I am telling, there are three crucial nodes here. First node is root node. Okay, second node is internal nodes, also known as branches. Third node is leaf node or leaves. Okay, the root node is the main node. The root node split into various branches or internal nodes. The internal nodes split into various leaf nodes or leaves. Okay, root node is the main node. The characteristics of the internal node or branches is see the internal nodes or branches has arrow pointing towards it as well as arrow pointing away from it. Okay, so that is one of the characteristics of the internal node. And the characteristics of the leaf node is, it has only arrow pointing towards it, not away from it. Okay, so that is why it is known as leaf node. This leaf node is also used for prediction. Okay, so this whole is known as decision tree. Okay, now let's move on to this three things: entropy, information gain, and giniindex. Now, how to construct a tree? So to construct a tree, we have these three important parameters: entropy, information gain, and giniindex. Okay, so what is this entropy? Entropy in a decision tree is a measure of uncertainty or impurity in data set. It quantifies amount of disorder or randomness in the data and is used to determine how a decision tree splits the data at each nodes. Okay, that is the definition of entropy. So it is denoted by this formula. Entropy will be denoted by minus sigma I equals to 1 to n. I equals to 1 to n means these are the classes. Okay, I equals to 1 first class, I equals to 2 second class, dot dot dot, I equals to n nth class. Pi, the probability of that class. Okay, and yeah, pi is the probability of that class belonging to the whole set. Okay, so that this is the entropy formula. Now we will do the computation with the help of a numerical example. So this is the example. Here there are this is the instances. The instances is nothing but serial number. So this is not exactly input. This you can neglect. Okay, other you have three attributes or input: a1, a2, and a3. A1 will take two values, true as well as false. A2 also same thing, true as well as false. A3 is taking some numerical values, right? 1 6 5 4 etc etc. So A3 is taking the numerical values. Now target class is the output. Okay, so we have three input and one output. Output, you have two classes, one is plus positive and another was is negative. Okay, so you have two types of classes here. Now first thing, our first purpose is the entropy of the training example. Means we have to find the entropy of the prediction set. Okay, so how we will find out? We will find out by this formula, that is we have four positive inputs, right? plus and plus. So 4 positive input and 1, 2, 3, 4, 5. 5 negative inputs. So according to our entropy formula, it is minus 4 by 9 minus pi. Pi is the probability of one class. So we are first talking probability of positive class, and then we will take probability of the negative class. So probability of the positive class will be minus 4 by 9, because 4 positive are there out of 9 examples. Okay, 4 positive examples out of 9 examples. So that is why 4 by 9, log base 2 4 by 9. And again we have to do for the negative class also. So negative, we have 5 example, right? 1, 2, 3, 4, 5. So that is why minus 5 by 9 log 2 5 by 9. So this is the entropy of our whole entropy of our training example, or you can say entropy of our prediction set. Okay, so is this clear up to this? Any doubt
Yes, sir.
how we find out this?
One doubt. This log to the base 2 using calculator, how do we calculate?
Log it to the power base 2, you can calculate. If you have scientific calculator, then you can put the base. Otherwise it is log base 10 or log base e, whatever, 4 by 9. So, let's say log, we have to find out log 2 a. Okay, we have to find out this log. Okay, let me erase it. Let's say we have to find out log base 2 and a. Okay, so this is equal to log any base. Okay, any base you can probably take 10 or log e, whatever in your calculator. So log e base 2 by log e base 2. Okay, so by this you can calculate, if your calculator does not have this provision. Okay, otherwise if your calculator has provision of putting the base, you can directly put the base. Otherwise you have to calculate by this formula, that is log any base. Two bases are very common in log. One is base e, and another one is base 10. So any base you can take. So log any base a divided by log any base 2. Okay, so by
Okay.
that you can calculate your thing. So this is about entropy. Okay, entropy of the training example, or you can say entropy of the prediction set. Okay, that we have calculated. But our next target is find out information gain. So what is this information gain? Information gain is nothing but it is a derived feature from your entropy. Okay, it is entropy of the whole set minus minus cross entropy of the input attribute. Okay, so that is information gain. So information gain in a decision tree is a measure used to determine which feature to split the data at each step. Okay, so earlier I have shown you a decision tree, right? But this is your root node. But if you have like 3 or 4 inputs, so how you will decide what input exactly you should use in the root node or any node like branch node also. So what is the input that you will use? So for that we have two parameter. One is information gain and second one is giniindex. So right now we are talking about information gain. So it quantifies the reduction in entropy or impurity of the particular split will achieve. Essentially it helps in selecting feature that will best separate the data into distinct classes. So I have told you information gain is nothing but entropy of your whole set minus cross entropy of the particular attributes. Okay, that is information gain. So entropy of the whole set we have just find out. Now if we can find out the cross entropy, we have just find out, right? Entropy of that whole thing we have just find out. Now if we can find out entropy of the cross entropy of the particular input attribute, then we can find out the information gain. Okay, now information gain with respect to a1. Okay, a1, right? Because we will take this two. Okay, this third we will not take, but we will focus on a1 and a2 because these are categorical these are categorical inputs. Okay, so that is why we will focus on a1 and a2. Okay, so information gain of a1. So again we have to find out the entropy. Okay, but earlier we have find out entropy of the whole set. But now as we are interested in A1, so that is why we will focus mainly on A1. Okay, so we will find out entropy of A1. So how we will find the entropy of A1? This thing is also known as, okay, okay, so this thing is also known as cross entropy. Okay, so how we will find out entropy of a particular attribute? So see, A1 we have two classes, right? True as well as false. So how many true we have? 1 2 3 4, 4 true, and 1 2 3 4 5, 5 false. Okay, and now what about our target class? For true, if we will only talk about true, then we have 1 2 3 4 1 2 3 4, yeah, 4 true example. But this attribute is contributing to the output. Whenever we are seeing the output, we can see out of this 5 true, okay, out of this 5 true prediction, we are getting positive only in 1 2 3. Only in 3 cases we are finding the positive output, okay, a positive predicted output. Other other example, like true we are finding positive, this true we are finding positive, but this true we are finding negative, and this true we are finding positive. That means we, in our A1 class, we have 4 true example, but out of this 4 true example, only 3 example is giving the positive prediction, another one is giving the negative prediction. Okay, so according to this we will find the entropy. So now how we will find the entropy? Now as we are focused on A1, so we will focus on A1. So A1 contributing to the output. So A1, I have told you, if I only take the true example, that is entropy ST, we are talking about A1 here. Okay, entropy ST means true examples, and we are talking about A1 here. So A1 we have A1 we have 1 2 3 4, 4 true example, that is why divided by 4. But in 4 also, only 3 example is giving you positive example, right, positive output. This true example is giving you negative output. So that is why 3 by minus 3 by 4 log 2 base to 3 by 4, minus 1 by 4 log base to 1 by 4. So by that we can find out entropy of true. Now how we can find out entropy of false example in respect to A1? Now a false example, 1 2 3 4 5, we have 5 false example. Out of 5 false example, 5 false example, one only is giving positive result, others are giving negative results. So 5 will be at the denominator, and in one case we will do 1 by 5, because only one is the one is giving positive prediction, others are giving negative predictions. So that is why minus 4 by 5 log base to 4 by 5. So when you will solve this, you will be getting 0.722. So is this step clear?
Sir, that can you just show that entropy one also? 4 by 9 here, that 9 is the total number, right? Whereas in the next
Yeah,
question, that
this is
denominator.
about entropy of the whole prediction set. Okay, prediction set or output set. Okay, so this is
Okay.
about entropy of the whole output set. But now we are talking about entropy of only one attribute, that is A1. Okay, now listen, in A1 we have two classes, right? One is true, another one is false. Now we have
Okay.
how many true example? 1 2 3 4, 4 true example.
Mm.
But this 4 true example, we have to see the output, because A1 we are not interested, we are ultimately interested in the output. So in this 4 true example, what we are seeing is this 4 true example, 3 are giving us positive result, this is giving positive, this is giving positive, and this true is giving positive, but this true is giving a negative prediction. Okay, so how we will write our entropy? So let me write here, A1 we have A1 we have 4 true example, right? But in this 4 true example, we have two things, 3 are giving positive and 1 is giving negative, right? 4 true example, but out of 4, 3 is giving a positive prediction, 1 is giving negative prediction. So how we will write our entropy with respect to true, because this is a true case. Okay, we are talking about only true. So how, okay, someone is joining. Okay, so yeah, so 4 true example, and out of 4 true example, 3 positive and 1 negative. So 3 positive, that is why 2 classes are making. This is one class and this is another class. So first class, how we will find out the entropy of the first class? Minus 3 by 4, 3 by 4 log 2 base 3 by 4, and 1 negative, that is why minus 1 by 4 log base to 1 by 4. Okay, so by that we will find out entropy of the true example with respect to, we are talking about a1. Now about a1 negative example, if we will say a1 negative example, so a1 we have 5 false, a1 we have 5 false example, right? Out of this 5 false example, we have out of this 5 false example, 1 2 3 4 5, we have 5 false example. Out of this 5 false example, only one example is giving positive prediction, others are giving negative prediction. So we will write 5 false, but out of 5 only one is giving positive, okay, and others are giving negative, 4 is giving negative. Okay, so how we will write our entropy? Our entropy will be 1 by minus 1 by 5 log base to 1 by 5, and minus 4 by 5 log base to 4 by 5. Okay, so by that we will calculate entropy of true as well as entropy of false. Is this clear?
Yes.
Okay, it is clear to everyone, right?
Yes, sir.
Okay. Now how we will find the information gain, because our aim is not entropy. In this slide our aim is to find the information gain of a particular attribute. So information gain is nothing but entropy of your whole set minus cross entropy of minus cross entropy of that attribute. Okay, so cross entropy, how we will find out for the attribute? Entropy we have already found out of the whole set in the previous slide, right? That is minus 0.911. Now how we will find the cross entropy? So cross entropy of the true example, we have to take the weighted thing here. Okay, so minus 4 by 9. What is this 4 by 9? In a1 we have 4 true example, right? We have 1 2 3 4 true example and 5 negative example. So that is why minus 4 by 9 entropy of this true set in a1, and minus 5 by 9. Why minus 5 by 9? Because false example we have 5 false example, that is why minus 5 by 9 entropy of the false example. Okay, so by that we can find the information gain, that is minus 0.9911 minus 4 by 9 into this thing 0.811 and minus 5 by 9 into 0.722. So by that we can find out the information gain of that particular attribute a1. Okay, is this clear? It is clear, right? Where we got 4 by 9 and 5 by 9, we have 4.
Yes, sir. Yes, sir.
Okay, no doubt, right? So any doubt in calculating information gain, entropy as well as information gain of particular attribute? It is
So
important
that
actually.
can you just repeat that 4 by 9 and 5 by 9?
Yeah, 4 by 9 and 5 by 9, right? So a1 you have 4 true example, 1 2 3 and 4. Okay, and proportion there are 9 total examples. So 4 by 9 minus 4 by 9 into your entropy of the true set in a1. Okay, similarly you have 5 false example, that is why minus 5 by 9 into entropy of your negative example. Okay, this is
Okay.
the formula. SV by S. S is the total number of examples in your attribute. SV is the particular population or proportion of one class in that attribute. So we are talking about true here, so that is why we have to take the true example. So that is why minus 4 by 9 entropy of ST and minus 5 by 9 entropy of SF, because we have 4 true example in A1 and 5 false example in A1. So that is why minus 4 by 9 entropy of ST, minus 5 by 9 entropy of SF. So you will get your answer 0.2295. Okay. So any doubt in this? No doubt, right? So similar way, exactly similar way, what we will do is, okay, someone is joining. Yeah, so exactly similar way, what we will do, we will find the information gain of A2. A2 again, we have this same thing, true as well as false set, right? Means we have two classes, true as well as false. Here we have 1, 2, 3, 4, 5. 5 true example and 4 false example. In 5 true example, what we are seeing is, we have two positive, negative, negative and negative. We have two positive and three negative. Okay, so actually here what will be the scene here, if I divide here, a2 will have 5 true example. Okay, a2 will have 5 true example. Out of 5 true example, we have 2 positive and 3 negative. 2 positive and 3 negative. Okay, so A2 we have 5 true example, 2 positive and 3 negative. That is why we will find the entropy, that is minus 2 by 5 log base 2, 2 by 5. Then 3 negative example, that is by 3 by 5, minus 3 by 5 log base 2, 3 by 5. Okay, so that is how we will find entropy of the true set in with respect to A2. Similarly, we will find entropy of the false set with respect to A2. Okay, A2 we have two true example and we have four, we have 1, 2, 3, 4, 4 false example, and in 4 false example, what we are seeing, we have 1 negative, 2 negative. We have 2 negative and 2 positive. Yeah, we have 2 negative and 2 positive. So minus 2 by 4 log base 2 by 4 minus 2 by 4 log base 2 by 4. Now when we will do our entropy, it is coming 1. Okay, and again we will find the information gain. Again we will find the information gain. So information gain, same thing, but here this thing proportion will change, because there are 5 true example here and 4 negative, 4 false example here in your A2. So that is why minus 5 by 9 minus 4 by 9. Okay, minus 5 by 9 entropy of true and minus 4 by 9 entropy of false. So by that we can find out the information gain, and information gain here is coming 0.0072. So is this clear? Any doubt in finding the information gain? Kindly let me know. Otherwise,
No, sir.
we will not move to the next slide. Otherwise, if it is not clear,
It is all clear, sir.
it is all clear, right? Okay. Now what we will do? We will be seeing another index for this splitting purpose, that is giniindex. Earlier slide we have talked about information gain. Now we will talk about giniindex. Giniindex or Gini impurity is another measure of impurity or disorder used in the decision tree. Very much similar to your entropy. It quantifies probability of a randomly chosen element being incorrectly classified if it was randomly labeled according to the distribution of classes in the data set. Okay. Okay, so now we will be finding out similar thing, whatever we have done with information gain. Similarly, we will do same thing with giniindex. Okay, but here as this is a giniindex, so here formula will be different. So giniindex with respect to true example, as I have already told you with the previous slide also, we have 3 positive and 1 negative. Okay, so giniindex, this is the formula, 1 minus sigma I equals to 1 to n. Pi is the probability of that class in that attribute. So we have I have already told you, here we have 4 true example, and out of 4 true example, 3 is giving positive and 1 is giving negative, right? So similarly here, according to the formula, it is 1 minus 3 by 4 square minus 1 by 4 square. So you will be getting 0.375. And Gini index with respect to false example, false. If we talk about A1 we have 5 false example, and out of 5 false example only one is giving positive prediction, other 4 are giving negative prediction. So how we will write it? We will write 1 minus 1 by 5, because 1 is giving positive, that is why 1 by 5, minus 4 by 5, because 4 are giving negative, that is why 4 by 5 is whole square, and that will be equal to 0.32. So again I am repeating, this is the formula of your Gini index. Gini index is 1 minus sigma I equals to 1 to n. What is I? I is the class. Okay, I is the class in that particular attribute. So I equals to 1 to n. Okay, pi whole square. Okay, pi is the probability of that class belonging to that attribute. Okay, so by that you will find Gini of true as well as Gini of false. Now that is not our aim. Our aim is to find the Gini index of the attribute. So the Gini index of the attribute is the weighted sum. Okay, now here it is the weighted sum. So weighted, again I have told you, A1 we have 4 A1, if you will see the table, A1 we have 4 true example and 5 false example. That is why okay, yeah, that is why 4 by 9 into Gini of true plus 5 by 9 into Gini of false. So that by that we will be calculating Gini index of that attribute, that will be coming 0.3444. Similarly we can calculate Gini index of the attribute A2. Okay, so any doubt in this? Should I explain this again?
Sir, please repeat again.
Yeah, please repeat.
Sir, please repeat again.
Yeah, please repeat again. Okay, so this is the formula of the Gini index, 1 minus sigma I equals to 1 to n pi square. Okay, now what is this I? I is the class belonging to that attribute. Okay, so I equals to 1 means first class, I equals to second means second class, I equals to n means nth class of that in that particular attribute. Now let us see our data. Okay, this is our data. So we are particularly focusing on A1 first. So A1 we have 1, 2, 3, 4 true example, and we have 1, 2, 3, 4, 5 false example. This is clear, right? Now if I see only the true example, we have 1, 2, 3, 4 true example, but 4 true example we are only getting positive prediction in 1, 2 as well as 3 example. In one example we are getting negative prediction. Okay, so that is what I have written here. A1 we have 4 true example. In 4 true example, 3 we are getting positive prediction and 1 we are getting negative prediction. And
Okay.
if I talk about the false example, we have 5 false example. Okay, you can see 4 are true and other 5 are false. So in false example, what we are seeing, we have 1 positive prediction and 4 negative prediction. Okay, up to this it is clear, right?
Yes.
Okay, now we will straight away put the formula. What is the formula? Formula is 1 minus sigma I equals to 1 to n pi whole square. That means 1 minus the positive prediction belonging to that attribute, that is 3 by 4, because we have 3 positive prediction. That is why 1 minus 3 by 4 square minus 1 by 4 square, because 1 negative prediction. That is why minus 1 by 4 square. Okay, so by that you will be calculating the Gini of true. Okay, that we are talking about A1 here. Okay, so A1 Gini of true will be 1 minus 3 by 4 whole square minus 1 by 4 whole square. So any doubt in this? No doubt, right?
No.
Yeah. Now Gini of false, same thing, 1 minus 1 by 5. Why 1 by 5? Because we have 1 positive prediction and 4 negative prediction. So 1 minus 1 by 5 whole square minus 4 by 5 whole square. So 1 minus 1 by 5 whole square minus 4 by 5 whole square. 1 is giving only positive prediction, the other 4 are giving negative prediction. That is why 1 minus 1 by 5 whole square minus 4 by 5 whole square. So Gini of false again, you know. Now our main aim is to calculate Gini index of that attribute, not only classes. Okay, so Gini index of that attribute will be equal to 4 by 9 into Gini of true plus 5 by 9 into Gini of false. Why 4 by 9 and 5 by 9? 4 by 9 means we have 4 true example, that is why 4 by 9. And why 5 by 9? Because we have 5 false example, that is why 5 by 9. So 4 by 9 into Gini of true, because these are 4 are your true examples, that is why 4 by 9 into Gini of true plus 5 by 9 into Gini of false, because we have 5 false example, that is why 5 by 9 into Gini of false. So by that you will find out Gini index of that A1. Okay? Clear, right?
In the information gain, how the entropy of S is calculated? At 0.99.
Entropy of the entropy of S is the your predicted, sorry, your output. Okay, S is the output set. Okay, so as in the output set you can see here are 1 2 3 4 positive prediction and 1 2 3 4 5 negative prediction. So what is your entropy? Entropy is given by this formula, that is minus I equals to 1 to n pi log base to pi. Okay, so I is the your classes in that attribute or set, whatever you tell, and I is your classes. Okay, so pi is the probability of that particular class in your set. Okay, so we have two classes, one is positive class and the one is negative class. So for positive class your entropy will be minus 4 by 9 log base to 4 by 9. You have 5 negative class, so minus 5 by 9 log base to 5 by 9. So by that you will be finding the entropy of your output set, that is entropy of S. Okay?
Thank you, sir. Thank you.
Okay. Now this is clear, right? Gini index also clear. Anyone any doubt regarding Gini index? No doubt, right?
So this is related to entropy, or the where do we apply that entropy and information gain?
Yeah. Information gain as well as Gini index will be applied for making a decision tree, creation of decision tree. Okay, that means which input we have to split and which we do not need to split. So for that we need to calculate this information gain as well as Gini index. That will be clear in the next example, but till now you just focus how to calculate it. Okay.
Okay.
Okay, so this is clear, right? Gini index as well as information gain. And in information gain, there is a thing called entropy. That is all is clear, right? These three things are clear: entropy, and then information gain, and then Gini index. Now the question is, which is the best splitting attribute between A1 and A2? So if we want to find the best splitting attribute, and there are two things, one is information gain and another one is Gini index. So in information gain what we see, the higher is the information gain of the attribute, the best it is the best split attribute. Okay, higher is the information gain, best is the splitting attribute. Okay, and Gini index is reverse of it. Lower is the Gini index, best is the attribute. So here we have calculated information gain of A1 as well as A2. So A1 is coming 0.2295, A2 is coming 0.0072. So as information gain of A1 is higher than information gain of A2, so that is why A1 is your best splitting attribute according to information gain. Okay, clear? Now what about Gini index? Gini index of A1 is 0.3444. Gini index of A2 is 0.4889. So Gini index, the lower is the Gini index, best is the splitting attribute. So lower Gini index, A1 has the lower Gini index, that is why A1 is the best attribute. So again I am repeating, there are basically two methods to split, to know which is the best input to split. Okay, first is information gain, second is Gini index. Information gain, higher the information gain, better the splitting attribute. Gini index, lower the Gini index, better is the splitting attribute. So A1 has more information gain, higher information gain, that is why A1 is the best split attribute. Out of A1 and A2 with respect to Gini index, A1 has the lowest Gini index, that is why it is the best split attribute. Okay, clear, right? Clear, right?
Yes.
Yes.
Okay. Now we will see same thing. We will see how to now earlier example what we have seen how to compute the entropy, information gain as well as Gini index. Now in this example, what we will see, how to use that Gini index or information gain, any particular, either you use Gini index or you use information gain, anything with that any with that any formula, how you can create a decision tree. So that we will see in this example. So this is the example. We have weekend w1, w2, w3. This is basically serial number. This is not input. Okay, this is, you can say, serial number. And then we have three input: weather, parents, money, and we have one output, that is decision. Okay, so weather takes how many classes? One is sunny class, one is windy class, one is rainy class. So weather has three classes: sunny, rainy and windy. Weather has three classes. Parents have two classes, yes or no. Money have two classes, rich as well as poor. Your output has one cinema, one class is cinema, one is tennis, one is stay in, and another is shopping. Your output has four classes. So is the data set clear to all of you? Data set
Yes.
clear, right?
Yes, sir.
Okay. Now what we will do, we will use Gini index and we will see how we can create a decision tree. So first compute Gini index for the overall collection of the training example. So Gini index, how to find out the overall Gini index? Overall Gini index, what is the formula of Gini index? Gini index is 1 minus sigma pi square. I is the classes. So as we are talking about the whole set, so as we are talking about the whole set, so in whole set we have how many classes? Four classes. Okay, one class is cinema, another class is tennis, another class is stay in, another class is shopping. Okay, so we have four classes. Out of this four classes, how many examples we have? We have 10 examples. Okay, out of this 10 examples, cinema 1 2 3 4 5 6, we have 6 instances of cinema. We have 2 instances of tennis, and we have 1 instance of stay in and 1 instance of shopping. Okay, so that is why Gini index of the whole set, how it is calculated? 1 minus sigma pi square. Okay, so sigma pi square, first class is cinema we have 6 example, that is why 6 by 10 whole square. And then tennis we have 2 example, that is why 2 by 10 whole square. Stay in we have 1 example, 1 by 10 whole square, and shopping we have 1 example, that is why 1 by 10 whole square. So this is the Gini index of your whole class. So up to this it is clear, right?
Yes, sir.
Okay, now let's
Yes.
move. Yeah, let's move on to particular attribute. So how many attribute do we have? We have 3 attribute. This is weather, this is parents, and this is money. So we have 3 attributes. Okay. So first let's take weather. So weather, if I talk about, okay, weather. Okay, where is the weather? Yeah, this is middle one is the weather. So if I talk about weather, we have 3 sunny example. Okay, 3 sunny example. Okay, and we have 3 rainy example, 1 2 1 2, and another one is, yeah, we have 3 rainy example. We have 1 2 3 sunny example, 3 rainy example, and 1 2 3 4 windy examples. Okay, now out of this if I talk about only sunny, okay, sunny, if I talk about sunny, in sunny you can see when weather is sunny, there are 2 example with cinema and 1 with tennis. Okay, so how we will find Gini of sunny? That will be equal to 1 minus 2 by 3, because 2 example of cinema, that is why 2 by 3. Sunny we have 3 example. In 3 we have 2 for cinema and 1 for tennis. So that is why 1 minus 2 by 3 whole square, and 1 for tennis, that is why 1 by 3 whole square. So by that we can find out Gini of sunny. Now how we can find out Gini of rainy? In rainy we have 2 example. Okay, rainy we have 2 example. Rainy, yeah, rainy we have 3 example, not 2 example. We have 3 example. 3 example you can see. 1 is cinema. Sorry, 2 is cinema. This is also cinema. This is also cinema. So 2 cinema and 1 stay in. Okay, so when your weather was rainy, 2 are example of cinema and 1 is stay in. So your Gini of rainy is 1 minus 2 by 3 whole square plus 1 by 3 whole square. So that will be equal to 0.444. Now similarly we will talk about Wendy. If I see Wendy 1, 2, 3 as well as 4. So we have 4 Wendy example. Wendy example, this Wendy example eats cinema, this cinema, so 2 cinema, 3 cinema, in fact 3 cinema and 1 shopping. Okay. So Wendy example we have 3 cinema and 1 example with shopping. So that is why 1 minus 3 by 4 whole square plus 1 by 4 square. So that will be 0.375. Now weighted average how we will find out? You will find out your Gini of Sunny into your Sunny example. So Sunny, how many examples are there for Sunny? 3 example out of 10. So that is why 3 by 10. If I talk about Rainy, how many we have example for Rainy? We have 3 example for Rainy. Then that is why again 3 by 10. And Windy, we have 4 example. That is why 4 by 10. So by that we are finding Gini index of the weather, that is coming 0.416. So is it clear? Any doubt?
So this Gini for sunny and rainy, those are like weights that we are multiplying to
Yeah,
that probability. Okay.
3 by 10, 3 by 10 where it is coming, right? So yeah. So Sunny, you have how many example of Sunny? 1, 2, 3 example of Sunny. So that is why weighted, whenever we will do weighted, we will do 3 by 10 into your Gini index of Sunny. So that is only written 3 by 10. Similarly for your Rainy, you have 3 example, that is why 3 by 10. For this Windy, we have 4 example, that is why 4 by 10. Okay.
Okay, sir. Thank you.
Okay. Now similarly, we have calculated Gini index for weather attribute. So one attribute we have calculated. Very similarly, we will find Gini index for money as well as Gini index for parents. Okay. So Gini index of money, money we have only 2 classes, that is rich as well as poor. Parents also same, 2 classes, yes as well as no. So similarly we will find out Gini index of Gini index for money as well as Gini index for parents. And when we are comparing, we are finding out that Gini index is least for which one? Gini index is least for parents, right? So that is why we will our first node or our root node we will split with parents. Okay, so again I am repeating, this Gini index is used to split your attribute. Okay, so best split will be whose Gini index is least and whose information gain is maximum. So as we are talking here only for Gini index, so here we will see which of this attribute Gini index is least. So we are seeing Gini index is least for parents. So that is why we will first split our node with respect to parents. So earlier this was our table, right? Now we are splitting it with respect to parents because for parents Gini index is least, that is 0.36. So that is why we are splitting with respect to parents. Okay. So any problem up to this? Any problem up to this? Gini
No,
index,
sir.
Gini
Clear.
index is least for parents. That is why we are splitting our we are first splitting with respect to parents. So parent is our root node. Okay, so parent is our root node. So that is why we have split it with respect to parents. So parents we have one part parents, as we have 2 classes. One is yes as well as another one is no. That is why we are splitting, first part is yes and another part is no. So first part you can see, whenever parents eats yes, all the decision are coming cinema. Okay, and whenever the parent is no, your decision is somewhere tennis, somewhere cinema, somewhere shopping, somewhere staying. So all the 4 decisions are coming. But here whenever your parents is yes, all your decisions are coming cinema. So actually this attribute we can remove, or this is your leaf node. Why this is your leaf node? Because this is not your branch node, and this is your leaf node because all your decision is coming cinema. Whenever your parent is yes, all your decision is coming cinema. So actually this is your leaf node, means in this node we will not split further. But here your decision is mixed, sometimes tennis, sometimes stay in, sometimes cinema, sometimes shopping, all the 4 attributes. So that is why in this node we can split, or this is actually your branch node but this is your leaf node because all the decisions are coming same. So in this node we will further not split, but in this node we have to again split. So again how we will split? Again we will split by similar process. Okay, now in this node, as we have already decided, parents we have decided. Okay, so this is this we don't have any attribute. Now here also you can see here also money you can see both you have rich as well as poor. Here weather you can see you have sunny, rainy as well as windy. So we will be splitting our node with respect to either weather or money. How we will decide? We will again calculate the Gini index with respect to weather as well as with respect to money. So now this is your set, right? Because this we have to split. So this is again I have shown here. So we have 1 2 3 4 5. We have 5 decision. Okay, means we have 5 example here and 5 example parents, because parents is our node. So this we cannot split. We have to split with respect to weather or with respect to money. We will decide on the basis of Gini index. So let's say Gini index for parents. No, so first we will let's split with the weather attribute. So weather attribute, now you can see we have weather attribute. We have how many sunny example? We have 2 sunny example. We have 1 rainy example and we have 2 windy example. So again we will calculate Gini index for sunny attribute, Gini index for this Gini index for this Gini index for sunny attribute. Whenever we are taking sunny attribute, we have 1 tennis decision. We have both the tennis decision. Okay, so sunny attribute, whenever your attribute is sunny, we have both the tennis decision. So that is why 1 minus 2 by 2 whole square. Now if I talk about rainy, then rainy we have only 1 example, and 1 example it is giving you stay in. So that is why 1 minus 1 by 1 square. Now okay, someone is joining. Okay, now windy we have 1 2 windy example. Okay, windy example, 1 is giving cinema, 1 is giving shopping. So we have to do 1 minus 1 by 2 square plus 1 by 2 square. So it is coming 0.5. Now we will do the same thing, that is weighted. How we will do the weighted? Here it is 0 into, because Gini index is coming 0, but sunny you have 2 example. Out of 5 you have 2 example, that is why 2 by 5. Gini index for rainy, again it is coming 0, but you have rainy you have 1 example, that is why 0 into 1 by 5. Windy you have 2 examples, that is why 0.5, that is windy coming 0.5, that is why 0.5 into 2 by 5, so it is coming 0.2. Okay, so weighted average for weather when the parent is no, that is 0.2. Now we will be calculating weighted Gini index for your money attribute, and when we will so similarly we will be calculating Gini index for your money attribute. Okay, so money attribute, there are 2 classes, one is rich as well as one is poor. Whenever there are rich, there are 1 2 3 4 rich example and 4 rich example. One is tennis, one is stay in, 2 are tennis, in fact 2 are tennis, one is stay in and one is shopping. So by that we can find Gini index with respect to this rich attribute. Similarly we will find Gini index with respect to poor attribute, and then we will find the weighted Gini index with respect to money attribute. Now we will compare these two, and wherever we are see that Gini index is less, we will be splitting with that attribute. So here we are seeing that Gini index is coming less for this windy attribute. That is why we will split our data now with respect to windy attribute. Okay, so yeah, windy attribute, that is why weather weather attribute, we will be splitting our data with respect to weather attribute. Okay, so out of this weather and money, our Gini index is coming less for this weather attribute. That is why we will be further splitting our data with respect to this weather attribute. Now further again we have to do the same thing. So now we are splitting our data with respect to weather attribute. So whether we have three things, one is sunny, one is rainy and one is windy. So whenever we are splitting with respect to Sunny, our decision is only coming 10x. Whenever we are splitting with respect to Rainy, our decision is coming stay in. Whenever we are splitting with respect to Windy, there are two decisions coming, either cinema or shopping. Okay, so now we can easily make our decision tree. So how can make our decision tree? First we have split it according to this Gini-index calculation. We have splitted our tree firstly with respect to parent attribute. So our parent is our root node. Okay, so root node we have written parents. Okay, root node we have written parents. Now this parent has two classes, right? Yes as well as no. We have seen whenever the parents was yes, the decision was coming cinema. Okay, so that is why whenever the parent was yes, we have written it cinema. So this cinema is your leaf node. Why it is leaf node? Because further it cannot be splitted. That is why this is split node. But whenever your decision was no, means whenever your class was no for parents, again you have to split. So again we have split with respect to weather. Weather we have seen three things, that is windy, rainy and sunny. Okay, windy we have okay, whether why we will why we will be splitting with respect to weather, because whenever we have compared with respect to weather or this money attribute, we have seen the weather attribute winning because it has less Gini index. So that is why now we will split with respect to weather. Weather we have three classes: windy, rainy and sunny. Now whenever your weather was sunny, it is giving the decision 10s. Okay, so this is again becoming the leaf node. Whenever it is rainy, again whenever it was rainy, the decision was stay in. But whether when it was windy, you have to split with respect to money. Okay, so money, there are two things, rich as well as poor. Rich you will be giving shopping, poor you will be giving cinema. So by this we have created a decision tree. So any doubt in this? Any doubt in this, how we have created the tree? Any step, any doubt?
Similarly, we can try for this information gain also, is it, sir?
Yeah, exactly same thing.
Do we get the same output or it may
Yeah,
depends?
you will get the same output, you will get the same decision tree, only your
Okay,
calculation will be
okay,
different. Okay,
okay.
so no doubt, right, how we have created the tree?
Is there any chance that we will get a different outputs
No, no,
for
no.
information gain and Gini?
No. There is no chance, because both are measures of impurity. Okay, your value would be different, but your answer would be same. Okay. Okay, so I hope it is clear. So what we have learned till so far, what is the decision tree, what is this information gain, entropy, information gain and Gini index. And then we have solved two example. In first example, what we have done, we have only focused on how to compute this index. In the next example, we have focused on how to create a decision tree. Okay, so now we will be straight away jumping on to the question answer session. So question answer session, please guess this question, guess this answer, and then we will be discussing the answers. Okay, so this is the first question. Yeah, this is the first question. The value of information gain in the following decision tree is option A is 0.380, option B 0.620, option C 0.190 and option D 0.477. This is your question. Okay, this is your question. So this is the root node and these two are leaf nodes. Okay, so root node, you can see entropy here is 0.996 and you have 30 example and you have divided into two leaf nodes, one with 17 example with entropy 0.787 and another with entropy 0.391 with 13 examples. Okay, so up to this it is clear, right? Question, it is clear, right? No doubt regarding question, right? Now we have to solve the question, that is we have to find the information gain. Okay, so what is the formula of information gain? Information gain is entropy of the whole set minus cross entropy of the attribute. Okay, so that is information gain. Okay, now here we don't have attribute, we are directly splitting into leaf nodes. That is why our information gain will be equal to entropy of the whole set. Entropy of the whole set is entropy of your root node. So entropy 0.996. So that is the entropy of your whole node. Again, let me show you the formula. Yeah, where is the information gain? Yeah, this is the information gain formula, that is entropy of the whole set minus cross entropy. Okay, so that is the formula of the information gain. So entropy of the whole example or whole set is, entropy of the whole set is given 0.996. Now we have to find out the cross entropy. Cross entropy, if I talk about this leaf node, then entropy will be 17 by 30, because here you have to take the proportion. So that is why 30 example out of here it is 17 example is giving you entropy is 0.787. So that is why minus 17 by 30 into 0.787, and then we have to again minus this. So that is why plus, as we have taken minus common, that is why I have taken plus here. So plus 13 by 30, because we have 13 examples, so 13 by 30 into entropy of this leaf. So 13 by 30 into 0.391. So our information gain is coming 0.380. So option A is our correct answer. Okay, so any doubt in this? Very simple question. Any doubt?
No, sir. Clear. Clear, sir.
Okay, no doubt. Anyone? No doubt, right?
Yes, yeah.
Okay.
No doubt, sir.
Okay, so let's move on to the next question. Which of the following properties are characteristic of the decision trees? Option A, high bias. Option B, high variance. Option C, unbounded parameters set. Option D, none of the above. Any guesses for this? Yes, Sandeep is telling C. Any other guesses? Okay, so talking about decision trees are generally unstable. Considering a small change in the data set can result in very different set of splits, because it all depends on data, right? We have solved the example, it all depends on data. Whatever information gain or giniindex we will find out, it all depends basically on data. So any one different data, if in any class we have out of, like we have 9 instances, earlier it was 4 and 5, now you have reversed 5 and 4, 5 or 4 or 3 or 6. So uh, ultimately your information gain or anything, it will get changed. So that is why this decision tree has high variance. Okay, so option B is true. Second thing is, decision tree do not make any assumption about distribution of the data. Okay, they are non-parametric methods where number of parameter depends solely on data. Okay, whatever data is there, in data how much classes are there and how we can split the reason, according to that your decision tree will be created. Okay, so that is why this decision tree is also known as non-parametric method. Means the parameters will only depend on your type of data, or how large your data set, or how many classes are there. It depends fully on data, not on any other parameter. That is why it is known as non-parametric method. Okay, that is why B as well as C is your correct answer. Okay, so B as well as C is your correct answer. So
So
let's
non-parametric means what do you mean?
non-parametric means, earlier whenever we are talking about any means linear regression or anything, we are talking about parameters, right? Beta 1, beta 2, beta 3. Okay, how many inputs are that many parameters, right? How many are input that many parameter, or one more than that parameter, right? But here your parameter directly depends on your data set. not on your number of inputs or etc. So that is why these are known as non-parametric methods. Okay, your linear regression or logistic regression all have parameters, beta 1, beta 2, beta 3, etc. Right? But here we do not have parameters. The parameter you can say that is only split, and that only depends on your data, and we have not any parameter that is related to directly with your input. That is why these are known as non-parametric methods. Where number of parameters solely depends on the data set on which training is carried out. Okay.
Okay.
Okay, so let's move on to the third question. Entropy of a 50-50 split between two classes is option A is 0, option B 0.5, option C 1, and option D none of the above. 50-50 split. What is 50-50 split means? Means if you have 4 example and you have two classes true and false, so 2 true example, 2 false example. So that is 50-50 split. Okay, so again I am
Zero.
repeating. If you have like 10 data, if you have classifying into 2 sets, mango, apple. Okay, so mango you have 5 example, apple you have 5 examples, so that type of data is known as 50-50 split. Okay, because 5 example of one set, 5 example of another set, so number of example if same in both the classes, so that is known as 50-50 split. Okay, now we are asked to find out entropy for that 50-50 split. So any guesses for this?
0.
Okay, someone is telling A0. Okay, let's see. So entropy, same formula, that is minus sigma I equals to 1 to n pi log base to pi. Okay, so 50-50 split means let's say we have we have 2x data. Okay, 2x data, okay, 1x belonging to one class and 1x belonging to another class. Okay, 1x belonging to, let's say, true class, 1x belonging to false class. So our how we will calculate this? We will calculate this by formula. So what is the formula? Pi will be 1 by 2, 1 by 2 for let's take the true example first. So your pi will be 1 by 2, that is 0.5, into log base to 1 by 2. So log base to 1 by 2 means it is minus 1. How it is minus 1? Because log base to it is 1 by 2, that is why it is minus 1. Okay, so 0.5 into minus 1, that is minus 0.5. Now we were talking about this false example. So false example, again we have 1x 1x proportion out of 2x, that means 1 by 2, that means 0.5. Again log base to 1 by 2, that is minus 1. So when you solve it, it will come minus of minus 0.5 minus of minus 0.5. That means minus of minus 0.5 is 0.5 and minus of minus 0.5 is 0.5. So 0.5 plus 0.5, that is 1. So option C is your correct answer. Got it, right? Direct formula we have to apply. 50-50 split means if we have 2x data, 1x belonging to one class and another 1x belonging to another class. So by that we can directly calculate with this formula. Okay? Got it, right? No doubt in this, right? It is a very easy question.
Yes, sir.
Okay, so let's move on to the next question. It is a big question it seems, but we will read the question and understand it step by step. So having built a decision tree, we are using reduced error pruning to reduce the size of the tree. Means we have several nodes. Now one nodes it was earlier splitting, but now we have to cut that split. Okay, so that is why that is known as pruning. Pruning means removing the branches of a particular node. Okay, so that is pruning. So we select a node to collapse. That means if one node is giving two subsequent nodes, so we are collapsing that node. Means now we are making it only one node. Earlier there was a node, it was giving you 3 split. But now as we are doing the pruning, what we are doing, we are collapsing all 3 branches, we are cutting all 3 branches, or we are simply erasing these branches and we are only left with one node. So that process is known as pruning. Okay, that process is known as pruning. So a particular node on the left branch, there are 3 training data points. So left branch, this is the left branch, we have 3 training data points, 5, 7, 9.6. Now on the right branch, this is a right branch, there are 4 training data points, that are 8, 7, 9.8 and 8.7, sorry, 8.7, 9.8, 10.5 and 11. So we have 4 data points on the right nodes. So what were the original responses for the data points along 2 branches, left and right respectively, and what is the new response after collapsing the node? So whenever there has been given many data and you have been told to find the actual response of a particular branch, what you will do, you will simply calculate the mean of that data set. Okay, so here in the left side you have 3 data points, 5, 7 and 9.6. You will simply take the mean, and that will be equal to 21.6 divided by 3, and that will be equal to 7.2. So your response, okay, original response, we are talking about original response first. Okay, so original response on the left node, that are 5, 7 and 9.6. So you will take the mean, so 5 plus 7 plus 9.6 divided by 3, so that will be equal to 21.6 divided by 3, so that will be equal to 7.2. So your right answer will be either this or either this. Okay, now we will talk about right node. Right node, we have 4 data points, 8.7, 9.8, 10.5 and 11. Okay, so whenever you will do the calculation, together it will be giving you 40. 8.7 plus 9.8 plus 10.5 plus 11, that will be giving 40. And 40, again you have to take the mean of it, so 40 divided by 4, that is 10. Okay, so right node, the response you will get original response. Okay, now we are only talking about original response. So original response 40 by 4, that is 10. So again our answer will be between these two. It is not clear. But now the third question or the third bit is, what is the new response? So how you will find the new response? So your new response will be find out when you are collapsing the nodes or deleting the branches. Now you have 7 data points, right? You have 7 data points, 3 of here and 3 of here. 3 of here you have mean something, 4 of here you have mean something. Okay, so your new response will be 3 by 7, because here you have 3 responses, that is why 3 by 7 into mean of this, that means 3 by 7 into 7.2, plus here you have 4 responses, that is why 4 by 7 into 10. Okay, 4 by 7 into mean of it, that is 10. So 4 by 7 into 10. So when you will solve it, you will find out 8.8 is the answer. So option C is your correct answer. Yeah, option C is your correct answer. So is this clear?
So that why that into 3.3 by 7 and into 4 that
Whenever
by
we are finding the, whenever we are collapsing the branches or pruning, okay, so our new response will be a weighted sum of response on both the side, here also, here also. Okay, weighted sum, because here we have 3 example and here we have 4 example, so ultimately we have 7 example. Here we have 3 example with mean something, so our weighted sum will be 3 by 7 into this. Now here we have 4 example. Okay, that is why our weighted sum will be 4 by 7 into the mean of this, that is 10. So that is why our new response is coming 8.8. So option C is your correct answer. Okay.
by response, what is the meaning of that word response?
Response means you can say a collectively uh, collectively combination of that data. Okay. So
Okay.
collective combination of your data is ultimately the mean. Okay.
Okay. So it's not just calculating average; it should be that weighted.
Yeah. Okay, now we will be okay. So this question is clear to all of you, right? Okay, so let's move on to the next question. Consider a dataset with only one attribute, categorical, means only we have one input. Suppose there are q unordered values in this attribute. Okay, q unordered values. How many possible combinations are needed to find the best split point for building the decision tree classifier? The decision tree only makes binary splits. Okay, So option A q, option C, option B q square, option C 2 to the power q minus 1, option D 2 to the power q minus 1 minus 1. Okay, so whenever we are talking about combination, so again you have to understand about permutation and combination. So whenever we are splitting q unordered values into sets, so there are possible 2 to the power q sets, or number of subset you will got is 2 to the power q. Okay, so you can check this, like you have 3 sets 1 2 3. Okay, it will be equal to total number of combination or total number of subset you can make is 2 to the power 3. Okay, so that means the total number of subset you can make is 8. Total 8 number of subset you can create. Okay, or let's take a less example, right? Let's take only 1 and 2. Okay, that will be much clear to you. Let's take only 1 and 2. Okay, 1 and 2. So total number of subset here will be 2 to the power 2, because we have 2 elements. Okay, 2 to the power number of elements, so that is 4. So what are the subset here we can make? Either we can make a null set. Okay, this is a null set, means no value in the set, or either we can take the complete set, that is 1 as well as 2. Okay, let me erase this. Okay, so we have we have to make 4 subset. Okay, so we have 2 set, one is the empty set, one is the full set. Now what are the other 2 set? Other 2 set can be 1 2, sorry, other 2 sets can be 1 and 2, right? So we have this 4 subset. Okay, that is why it is 2 to the power q. So that is why it is 2 square, that is 4 subset you can make. Now what happens in this subset is what happens in this subset is these 2 things, that is empty set as well as this empty set as well as this full set. Okay, this empty set as well as this full set, these 2 are not considered, because we have to do the split. So whenever we have to do the split into different number of set, we cannot consider an empty set, neither we can consider a full set. So that is why these 2 are erased. So we are left with only 2 square minus 2. So that is why 2q minus 2. So 2q minus 2 is the maximum number of subset you can get. Now what happens is whenever we are talking about combination, right? Combination like nc0, nc0, nc1 dot 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 ncn, right? So this ncn, if I take the next attribute, that is nc n minus 1, right? ncn minus 1. Now this attribute as well as this attribute are same. Okay, this attribute, this 2 we have deleted, because this is the 0 set, this is the full set. So that is why this 2 attribute we have deleted. That is why 2 to the power q minus 2. Okay, up to this it is clear. But now this set and this set are also similar. nc1 is equal to ncn minus 1. So that is why we have to take only one set. That is why we are dividing by 2. So your answer will be 2 to the power q minus 2 divided by 2. So whenever you will solve it, you will get 2 to the power q minus 1. 2 by 2 is minus 1. So that is why the option D is your correct answer. So again I am repeating, whenever you have been given q unordered values and you have to split it into different set, so the maximum number of subset you can get is 2 to the power q. But the problem with 2 to the power q is one set is empty set and one set is full set. So that is not a thing for split, because we are ultimately focusing on split. So that is why we cannot take this 2 set. One is empty set, one is the full set. So that is why we are not interested in this 2. So that is why we have cut this nc0 and ncn. Now we are left with this. But in this also we can see this nc1 is equal to ncn minus 1. Okay, that means we divide by 2, because the out of this remaining corresponding combination, if we talk about from the start or from the end, at the same position, this will yield the same set. So that is why this nc1 and ncn minus 1 is same. So that is why we have to divide by 2, so that only one will be counted, the other will not be counted. So that is why 2 to the power q minus 2 divided by 2, that is 2 to the power q minus 1 minus 1. So option D is your correct answer. Okay, is it clear?
Uh, from that 2 raised to q minus 2 divided by 2, how you got that option D?
Option D, this is right. Option D is 2 to the power q minus 1 minus 1. So this is 2 to the power, what I have told you, 2 to the power q minus 2 divided by 2. Now 2 to the power q divided by 2 minus 2 divided by 2, right? So 2 divided by 2 is 1. This is 2 to the power q minus 1. Okay, so
Okay.
your answer will be 2 to the power q minus 1 minus 1. So this is your correct answer. So option D is your correct answer. So let's move on to the next question. Consider the following statement. Statement 1, decision tree are linear non-parametric models. Option B, statement 2, statement 2, a decision tree may be used to explain the complex function learned by a neural network. Okay. Option A, both the statement are true. Option B, statement 1 is true, but statement 2 is false. Option C, statement 1 is false, 2 is true. Option D, both of the statement are false. Any guesses for this? Yeah, so no guesses. So let's see. Yeah, Sandeep is telling A. Okay, that both statement are true. Okay, so decision tree are linear non-parametric models. Non-parametric is okay, but is decision tree linear? No, decision tree are non-linear models. Okay, so that is why statement 1 is false. So decision tree are non-linear models. They make predictions by splitting the data based on feature at each decision node, and the splits can be based on non-linear decision. For instance, a decision node might split the data based on whether a specific feature is greater than or less than or equal to a certain threshold. Okay, so that is why it is non-linear. So it is a non-linear, it is not a linear, it is a non-linear. Yeah, it is non-parametric, that is true, but it is a non-linear. So statement 1 is false. Statement 1 is false. Now second thing, a decision tree may be used to explain the complex function learned by a neural network. So what happens is a decision tree can be used as an interpretability tool. Yeah, the most important thing for a decision tree is it is used for a interpretability tool. It is used as the best interpretability tool. Other up to this, all the machine learning models you have discussed, linear regression, logistic regression, or anything SVM or artificial neural network, all are not well interpretable. Linear regression is okay, interpretable, but again if you talk about SVM or if you talk about neural network, these are not interpretable. Okay, these are not well interpretable. So what this decision tree can be done by this partitioning of this input space. A decision tree can provide insights into the region where the neural network make a specific prediction. So wherever the neural network was making prediction, in that we can fit a decision tree and we can properly interpret what exactly is happening in a neural network. So statement 2 is a true statement. So statement 1 is false and statement 2 is true. So option C is your correct answer. Okay. So again I am repeating, this is false because decision tree is not a linear model. Your linear model is linear regression, logistic regression, then this SVM. These all are linear models, but this decision tree are not linear, non-linear models. Okay, and second thing, a decision tree may be used to explain the complex function. Yeah, decision tree, as a decision tree is a perfect interpretability tool, so that is why it can be used to explain the complex function that is learned by the neural network. So that is why option statement 2 is true. So C is your correct answer. That is statement 1 is false, second is true. Okay, so let's move on to the next question. Consider the following data set. Yeah, this is our data set. So we have 1 2 3 4, yeah, we have 4 attributes. One is price we have 3 classes: low, medium and high. Maintenance we have low, medium and high. Maintenance also 3 classes. Capacity we have values 2 4 5, and yeah, 2 4 and 5, right? 2 4, yeah, 2 4 and 5. So in capacity we have 3 classes: one is 2, one is 4, and one is 5. Okay, airbag we have 2 classes, no and yes. Yeah, profitability we have 2 classes, yes and no. So we have to, what we have to do, which of the attribute would you select as the root of a decision tree? So again we have to find out either information gain or this giniindex. Okay, so information gain, what is information gain? Information gain is entropy minus the cross entropy. So cross entropy, information gain should be as high as possible, but this cross entropy should be low as possible. What I am telling? Okay, let's see the formula. Yeah, this is your formula for information gain, right? So this is the entropy of the whole data set, and this is the cross entropy. So if your entropy is fixed, the higher is your cross entropy, the lesser is the information gain, or lesser is the cross entropy, higher is the information gain. So lesser is the cross entropy, higher is the information gain. Higher is the information gain, high is the better is the splitting attribute. Okay, so better is the attribute for splitting. So yeah, information gain should be high as possible, giniindex should be low as possible. Similarly, cross entropy, I mean this part should be sorry, not this part, only this part should be not minus of this part, only this part. So this part should be yeah, this part should be as low as possible to have a better split. Okay, because this is fixed, this how much high it would be, how much low it would be, better is your information gain. So that is the thing. So we have to find we have to find the attribute with lowest cross entropy. So we will find for price we have price we have first we will talk about low. So low we have 1 2 we have only 2 example, 1 2 low we have only 2 example, right? Yeah, low we have price, right? Yeah, low have 1 2 3 4, yeah, price, this is the price. Okay, price we have low 1 2 3 4. Low we have 4 example, medium we have 4 example, high we have 3 example. Means total out of 11, 1 2 3 4, 1 2 3 4, 1 2 3, out of 11 examples we have 4 low, 4 medium and 3 high. So out of this 4 low, what we are seeing, out of this 4 low, 1 is yes no, yes no, means out of this 4 low, 2 is yielding yes and 2 is yielding no. So our cross entropy will be minus 2 by 4 log base 2 by 4, minus 2 by 4 log base 2 by 4, and as we have 4 low example, that is why 4 by 11. So this is about low. Similarly, we can calculate this about medium. Medium we have again 4 example of medium. Medium we have 1 2 2 yes, yeah, 2 no, 2 yes. Yeah, medium also 2 low, 2 no and 2 yes, that is why minus 2 by 4 log base 2 by 4, minus 2 by 4 log base 2 by 4, and weighted because 4 medium example are here, 4 by 11, 4 by 11 to find out the weighted. Similarly, for high also we can calculate what is the cross entropy, and whenever we will be adding the cross entropy for all the classes, we will be finding the cross entropy of that particular attribute. Okay, so that is coming 0.977. Similarly, we can find cross entropy of maintenance, capacity as well as price. And what we are seeing is cross entropy of capacity is coming less. That means information gain of this value will be, capacity will be most. So that means capacity capacity will be our root node. So option C is our correct answer. Okay, so any doubt in this? Any doubt? Am I audible?
Yes, sir. Clear, sir.
Okay. So let's move on to the next question. Again, what we have to do, what is the initial entropy of the malignant? Okay, malignant is your output class. So output you have two classes. One is 0 and another is 1. 0 you have how many instances? 1, 2, 3, 4, 5, 6, 7. 7 instances of 0 and 1, 2, 3, 4, 5. 5 instances of 1. So how you will find the entropy? Your total entropy of the set will be this minus sigma pi log to base 2 pi. So 7 will be 0 and 5 will be 1. So 7 by 12 7 by 12 log base 2 7 by 12 minus sign and minus 5 by 12 log base 2 5 by 12. So that will be answer will be 0.9798. So option B is your correct answer. Again a easy question. Here it has been asked to calculate the entropy of your total set, that is entropy of your output, that is this is your output malignant. Okay, so malignant you have 7 instances of one class and 5 instances of another class, so you can directly find out the entropy of the class, that is sigma pi log base 2 pi. Okay, so no doubt in this, right? Any doubt in this? Okay.
It's clear, sir. Thanks.
Okay, so which of the following is our major advantage of our decision tree over other supervised learning techniques? Only we have to pick one. Okay, so option A theoretical guarantee of performance, option B higher performance, option C interpretability of the classifier, or option D more powerful in its ability to represent complex functions. Any guesses for this? Yeah, Rakesh is telling C. Okay, any other guesses? Yeah, C. Sandeep is also telling C. Yeah, exactly. Option C is the correct answer, because whenever we are comparing this decision tree with our other supervised learning algorithm, this decision tree has the is the best interpretability tool. Okay, so decision tree are highly interpretable, which is one of the major advantage of this type of machine learning model. The model's decision can be easily visualized and understood, like we have seen in an example that we have created a tree. It is very easily visualized and understood, right, as it is clearly lays out the decision making process from the root to the leaf. So that is why option C is your correct answer. Again a easy question, but an important question, a very important question I will say, because this is the this is the major advantage of this decision tree over your other supervised learning machine learning models. Okay, clear, right? So let's move on to the last question of this day. Which of the following is true for a decision tree? Option A, decision tree is an example of a linear classifier. Option B, the entropy of the node typically decreases as we go down a decision tree. Option C, the entropy of a set increases with its purity. And option D, an attribute with lower information gain is preferred to an attribute with higher information gain. Any guesses for this? Any guesses? Okay, so option A is false, right? Option B, C, yeah. What about option D? An attribute with lower information gain is preferred than attribute with a higher information gain. Again false, because attribute with higher information gain is preferred for splitting, right? And lower Gini-index is preferred for splitting. And whenever we have talk about cross entropy, then lower cross entropy. Okay. So let's talk one by one. These two are false. So your answer will be between these two. So decision tree is an example of linear classifier. This is a false example. And decision tree are non-linear classifier because they can capture complex pattern in the data by partitioning the feature space into regions with different class labels. Okay, what decision tree do? It classified into different regions. That depends on your branches that you decide. Okay, now linear classifier like this logistic regression or linear regression or SVM, they separate the data with a straight line. In case of two attribute, in case of three attribute, it divide with a plane, or more than three attribute, it divides with a hyperplane. But these are a linear classifier, right? But this your decision tree is not a linear classifier. It splits your information into different reasons. Okay, so that is why it is a non-linear classifier. So option A is false. Now what about option B? The entropy of a node typically decreases as we go down a decision tree. So yes, as we move down a decision tree, the data is split into more homogeneous subset. Okay, meaning the uncertainty or entropy usually decreases. This is because each split aims to group similar instances together, reducing the disorder. Okay, so whenever we are coming from our this root node to the leaf node, what happens is our entropy decreases. That means randomness decreases. That is what we want to achieve, right? We want to achieve less impurity. So earlier our root node is very much impure, then we are dividing it into various branches, so it becomes somewhat pure, and until it comes to a leaf node it becomes fully pure. So that is why our entropy always decreases as we go down. So option B is true. What about option C? The entropy of a set increases with its purity. No, the reverse of this is true. The entropy of a set actually decreases with its purity. Entropy is a measure of impurity, not purity. Entropy is a measure of impurity. That is why more the cross entropy, less better is your splitting. Okay, or more the Gini-index, less better is your splitting attribute. Okay, so that is why this two, cross entropy as well as this Gini-index, is your measure of your impurity. Okay, so that is why the entropy of a set increases with purity. No, the entropy of a set decreases with its purity. Okay, so this is also a false example. And last, I have already told you, lower the information gain, higher the information gain, your attribute is more preferred for splitting than lower information gain. So option D is also false. So option B is your correct answer. Okay, so any doubt in this?
No, sir.
Okay, so by this I am ending the session for today. Any further doubt? So
So
you
this,
all understood, right, how to find out these three things: entropy, information gain, as well as this Gini index, right? That you all understood, right? Clear, right? And
yes.
also how to form a tree. That is also clear, right? Okay. So by this I am ending the session for today. Okay.
Sir, this misclassification error, how can we think about? Like we have to go on adding more
More branches.
these
Yeah, more
branches.
branches we will add. The lesser will be our bias.
Yes. Okay.
Okay, lesser bias means less will be the misclassification error. Okay.
Okay. So we have to calculate the misclassification error branch by branch and go on adding it. There is a problem.
Okay. Yeah. Means the more branches we will be splitting our data into, the lesser will be the bias, the more will be variance. Okay. Because you
Okay.
are making the model more complex. Okay.
Okay.
Okay. Okay. So by this I am ending the session for today. Thank you all of you. Okay.